Hello, this is Yashveen. In this video, I'll be solving paper 4, variant 2, February-March 2019, 0620 chemistry. Starting with question number 1. Period 3 of the periodic table is shown. So we have all of the elements in period 3. Answer the following questions using only these elements. Each element may be used once, more than once, or not at all. State which element A is a gas at room temperature and pressure. Alright, over here we have argon. B forms a basic oxide with the formula X2O. Basic oxide means that this is supposed to be an oxide made with metal and oxygen. But since magnesium, alright, so we have three metals over here. Aluminium has a charge of +2, magnesium has a charge, aluminium has a charge of +3, magnesium has a charge of +2, and sodium has a charge of +1. And so we need a substance over here which has a charge of +1, because as we can see over here, this charge 2 means it needs, this substance X needs two of its charges to cancel just one charge of oxygen, and oxygen has a charge of 2 negative, and that tells us that the substance over here should be carrying a charge of +1, and that over here is sodium. C is made of atoms which have a full outer shell of electrons, that is argon from the noble gases. D forms an oxide which causes acid rain, that is sulfur dioxide, which causes acid rain. So I'll write sulfur over here. E is extracted from bauxite, and that is aluminium. F forms an oxide which has a macromolecular structure, which means based on covalent bonds, but it has a huge structure, and that is silicon over here. G consists of diatomic molecules, and that is chlorine gas. A, the table gives information about some atoms or ions A, B, and C. Complete the table. Alright, so here the number of protons A is greater than the number of electrons, which means it is a charge, and the charge is going to be +1 since there is only one less electron. B, so as we can see over here, the charge is 0, which means the number of electrons and protons is going to be equal. And electronic structure is a 2 in the first shell, 8 in the next one, followed by 8 in the third shell. Number of protons and number of electrons. Alright, so here we have a charge of -1, which means there is one extra electron. So the number of protons is going to be 9. B1, carbon is an element. Define the term element. Alright. Carbon 12, carbon 13, and carbon 14 are isotopes of carbon. Complete the table. Alright, since these are isotopes, that means the number of protons and electrons is going to be the same, and the only difference is going to be number of protons, and we can calculate the number of protons by subtracting atomic number from the mass number. So here we have number of protons, which is the atomic number, same for all of the three isotopes, that is 6. Number of neutrons calculated by subtracting atomic number from the mass number is 6, 7, and 8. 3. Fluorine is a group 7 element. Fluorine forms compounds with metals and non-metals. Predict the physical state of fluorine at room temperature and pressure. So fluorine exists in gaseous form. 2. Fluorine exists as diatomic molecules. Complete the dot and cross diagram to show the electron arrangement in a molecule of fluorine. Show outer shell's electron only. Alright, so each fluorine is a group 7 element, which means it has 7 electrons in its outermost shell, and it only needs one electron, and both of these fluorine atoms are going to get that one last electron by sharing one with each other, and so it goes this way. So the bond here has 2 electrons, one from each fluorine atom. This completes the shell of this fluorine atom. So 1, 2, 3, 4, 5, 6, and 7. These are the electrons in this fluorine atom, and it's sharing one electron with the other one. And the other one is also sharing electrons in similar style. C. Write a chemical equation for the reaction between sodium and fluorine. Alright. So we have sodium plus fluorine, and this forms sodium fluoride. But fluorine exists as a diatomic molecule. So before the equation, I'm going to write 2 over here, and balancing it over here gives 2 sodium atoms as well. D. Explain why chlorine does not react with aqueous sodium fluoride. So as you can see in group 7, fluorine comes above chlorine, and that makes it more reactive than chlorine, and that is why chlorine cannot displace fluorine from any compound. E. Tetrafluoromethane and lead fluoride are fluorides of group 4 elements. Some properties of tetrafluoromethane and lead fluoride are shown in the table. Alright, so tetrafluoromethane over here is a compound which contains only nonmetals, which means it consists of covalent bonding. However, lead fluoride has a metal and a nonmetal, which means it is bonded together by ionic bonds due to opposite charges. And that is also clarified by the melting points over here. Since covalent bonds are weaker than ionic bonds, they have a much lower melting point and also boiling point. 1. What is the formula of lead fluoride? Alright, to write a formula, we first start by writing the symbol of the element. So we have lead over here and fluorine, followed by writing their relative valencies. So lead over here has the valency of 2, and fluorine is in group 7, so it has the valency of 1. So I'll cross the valencies then, and this gives the answer as lead fluoride with 1 lead atom and 2 fluorine atoms. 2. What type of bonding is present between atoms in tetrafluoromethane? So this consists of covalent bonding. 3. What type of structure does solid lead fluoride have? So it has a giant ionic lattice. 4. Explain in terms of attractive forces between particles why lead fluoride has a much higher melting point than tetrafluoromethane. In your answer, refer to types of attractive forces between particles and their relative strengths. Alright, so tetrafluoromethane consists of covalent bonds, meaning that it consists of bonds where the molecules only share their atoms in their last shells. However, lead fluoride is composed of ionic bonds due to forces of attraction between oppositely charged particles, and that is a bond which is much stronger than covalent bonds. So the answer goes F. Tetrafluoroethene is an unsaturated compound with the formula C2F4. Tetrafluoroethene is the monomer used to make the polymer polytetrafluoroethene. 1. What is meant by the term unsaturated? Alright, so as in here, since this is a compound of carbon, unsaturated means it has at least one double bond. To describe a test to show that tetrafluoroethene is unsaturated. Right, so the test is bromine water, and the observation is that the bromine water becomes colorless. And the reason that this happens is once a compound has double bonds, by adding bromine water opens up the double bonds and then it reacts with this bromine. So initially bromine was brown in color, but since it has now reacted with the compound, it loses its color and becomes colorless if there is a presence of double bond. But if the substance is saturated, that is to say the compound does not have any double bond, the bromine water does not react and it stays bromine itself, and so it maintains its brown color. 3. Draw the structure of a molecule of tetrafluoroethene. Show all of the atoms and all of the bonds. Alright. So tetrafluoro means 4 fluorine atoms, and eth means 2 carbon atoms, and ene shows that there is a double bond between those 2 carbon atoms. And this is the structure of tetrafluoroethene. 4. Tetrafluoroethene can be polymerized to form polytetrafluoroethene. Draw one repeat unit of polytetrafluoroethene. Show all of the atoms and all of the bonds. So the only difference is that the double bond opens up. And that's it. 5. Deduce the empirical formula of tetrafluoroethene. So empirical formula simply means the formula of a compound in its simplest form. So over here the formula is C2F4, and simplifying it gives the formula as CF2. And the formula of polytetrafluoroethene is also the same because the number of carbon and fluorine does not change. Question number 4. This question is about ethanoic acid. A. Ethanoic acid is manufactured from methanol and carbon monoxide. The process is done at 200 degrees Celsius and 30 atmospheres pressure. The forward reaction is exothermic. Complete the table using only the words increases, decreases, or no change. Alright, adding a catalyst. Does it have any effect on the rate? Yes. Adding a catalyst would increase the rate of any reaction. Increasing the temperature, effect on the rate of forward reaction. Alright, so the rate of forward reaction also increases because increasing the temperature would increase the rate of reaction of any reaction, no matter if it is exothermic or endothermic. Effect on the yield of ethanoic acid. Alright, so that yield is going to decrease. Since the backward reaction is endothermic, that would also be favored, so yield would decrease. Decreasing the pressure, effect on the yield of equilibrium yield of ethanoic acid. Alright, so increasing the pressure favors the side or the side of the reaction which has least number of molecules. So over here, this is the side, the product side has least number of molecules, and so it is going to be favored by increasing the pressure. But since here we are decreasing the pressure, the yield is going to decrease. B. How would you show that an aqueous solution of ethanoic acid is an acid without using an indicator or measuring the pH? state the reagent you would use, and give the expected observations. Write a chemical equation for the reaction that you decide. Right, so I'll start by naming the reagent as calcium carbonate. Right, expected observations are that bubbles form and the chemical equation goes calcium carbonate plus ethanoic acid gives the products as carbon dioxide and water and calcium ethanoate. Alright, so if you're confused, this one and this one is the parenthesis. This is CH3COO, parenthesis closed, 2 and Ca. So this is calcium ethanoate. And I'll have to now balance the equation, writing 2 over here. C. Ethanoic acid is a weak acid. 1. What is meant by the term acid? So an acid is a proton donor. 2. Why is ethanoic acid described as weak acid? Because it only partially ionizes. D. Ethanoic acid reacts with methanol to form an ester. 1. State 2 conditions required for this reaction. So we need heat and catalyst in the form of concentrated sulfuric acid. To draw the structure of an ester formed when ethanoic acid reacts with methanol. Show all of the atoms and all of the bonds. Name the ester. Alright, so naming the ester and drawing the ester have opposite methods. While naming them, you start with naming the alcohol over here, which is methanol, and end with the acid. So I'll start by writing the name of alcohol, which is methanol. So it's named as methyl ethanoate. However, while drawing the structure, you start by drawing the acid part of the group, which means we have two carbons from ethanoic acid. The second one bonded with oxygen with double bond, and another one with a single bond. And now I'll end this with methanol, which is the alcohol over here. 3. Name an ester, which is a structural isomer of the ester in D2. Alright, so the ester would have this double bond with the first carbon atom or the last one. That would be the same thing. Question number 5. Titanium is extracted from an ore called rutile. Rutile is an impure form of titanium oxide. A. Rutile is mixed with coke and heated in a furnace through which chlorine gas is passed. The product is gaseous titanium chloride. So we have the formula over here of titanium chloride. The gaseous titanium chloride produced is condensed into the liquid state. The titanium chloride is then separated from liquid impurities. 1. Suggests the name of process by which liquid titanium chloride could be separated from liquid impurities. So separating liquid from liquid can be done by fractional distillation. 2. Carbon monoxide is also produced in the reaction. Why should carbon monoxide not be released into the atmosphere? Because it is poisonous. B. Calculate the volume of chlorine gas at room temperature and pressure that reacts completely with 400 grams of titanium oxide using the following steps. Right. So first off, we'll start by calculating the relative formula mass of titanium oxide, and that means the relative atomic mass of titanium, which is 48, plus the relative atomic mass of diatomic molecule of oxygen, that is 16 into 2, and the sum of these two is going to be 80, which is the relative formula mass of titanium oxide. Calculate the number of moles in 400 grams of titanium oxide. So moles is equal to mass divided by molar mass, which is 400 divided by 80, and that gives the answer as 5 moles. Determine the number of moles of chlorine that react with 400 grams of titanium oxide. Alright, so as we can see over here, 1 mole of titanium oxide reacts with 2 moles of chlorine, that is double the amount of moles. So that should mean 5 moles of titanium oxide doubled would give us 10 moles of chlorine gas. Calculate the volume of chlorine that reacts with 400 grams of titanium oxide. So volume is equal to moles into the molar volume, and that is 10 moles into molar volume, which is 24 dm cube, and that would give the volume as 240 dm cube. C. Titanium chloride is heated with an excess of magnesium in an atmosphere of argon. 1. Balance the chemical equation for the reaction. Okay, so here we have 4 chlorine atoms, which means here also we should have 4 chlorine atoms in total, and we can gain that by multiplying 2 with this 2 over here. And so we need 2 magnesium atoms on the reactant side as well. 2. Titanium chloride can be reacted with sodium instead of magnesium. The reaction between titanium chloride and sodium is similar to the reaction between titanium chloride and magnesium. Write a chemical equation for the reaction between titanium chloride and sodium. Alright, so we have titanium chloride reacting with sodium for forming titanium and sodium chloride. The only difference over here is that magnesium and sodium have different charges. Magnesium had a charge of +2, and since chlorine only has a charge of -1, we need 2 chlorine atoms to cancel the charge of 1 magnesium atom. However, sodium has a charge of +1 and chlorine has a charge of -1, so they can cancel each other without having extra number of elements. And so we can balance this equation by writing a 4 over here and a 4 over here. 3. Suggest why the reaction between titanium chloride and magnesium is done in an atmosphere of argon and not air. Alright, so that's because air has oxygen, which is a reactive gas, and magnesium is also reactive. And if this was done in air, magnesium would have reacted with oxygen. Since argon is not reactive, it is completely inert, so it does not react with magnesium. D. After titanium chloride is heated with magnesium, the unreacted magnesium is removed by adding an excess of dilute hydrochloric acid to the mixture. The dilute hydrochloric acid also dissolves the magnesium chloride. The dilute hydrochloric acid does not react with titanium or dissolve it. 1. Give 2 observations and write a chemical equation for the reaction that occurs when dilute hydrochloric acid reacts with magnesium. Alright. So first, the magnesium solid dissolves, which is the first observation, and then hydrogen gas forms since this is a reaction between an acid and a metal. So I'll write effervescence is observed, which means formation of bubbles. Chemical equation goes magnesium reacting with hydrochloric acid, forming magnesium chloride and hydrogen gas. So I'll balance it now. 2. Name the process that is used to separate the titanium from the mixture after all the magnesium has been dissolved. So titanium would be solid and the rest of the mixture is liquid. So separating solid from liquid can be done by filtration. 3. Titanium does not react with dilute hydrochloric acid or dissolve in it. Suggest why titanium does not react with dilute hydrochloric acid. To be able to react with hydrochloric acid, the metal has to be more reactive than hydrogen, and that is to say, it has to come above hydrogen in the reactivity series. But titanium is far below hydrogen, which makes it less reactive than hydrogen, and that is why it cannot displace hydrogen from hydrochloric acid. E. Magnesium cannot be produced by electrolysis of aqueous magnesium chloride using inert electrodes. 1. Name the product formed at the negative electrode, which is the cathode, during electrolysis of aqueous magnesium chloride. Alright, I need to explain a bit of electrolysis over here. In aqueous magnesium chloride, I'll start by writing all of the ions present in it. So we have the positive charges as hydrogen and magnesium, which would be attracted towards the cathode. Now here it's the matter of being more reactive. Magnesium is more reactive, which makes it likely that magnesium would stay in its ionic form. It would not go towards the cathode to be made into a metal. Instead, hydrogen is less reactive than magnesium, so it would be deposited at the cathode. And that is why hydrogen forms over here at the cathode by electrolysis of aqueous magnesium chloride. Suggest how magnesium can be produced from magnesium chloride by electrolysis. It can be attained when magnesium is not given a choice. That is to say, we have no hydrogen at ions in the electrolyte, and that would mean using molten magnesium chloride instead of aqueous. Question 6. This question is about transition elements. A. Transition elements are harder and stronger than group 1 elements. Describe two other differences in physical properties between the transition elements and group 1 elements. Alright, so they have higher density, and they also have higher melting and boiling points. B. State one physical property of transition elements that is similar to group 1 elements. So all of the metals conduct electricity. C. State two chemical properties of transition elements. So these have to be distinctive properties that are not found in ordinary metals. So they have variable valencies or variable oxidation states, has the same meaning, and they also act as catalysts. D. Cobalt is a transition element. Anhydrous cobalt chloride is used to test for water. State the color change that occurs when water is added to anhydrous cobalt chloride. So the change occurs from blue to pink. E. Iron is a transition element. 1. Which two substances react with iron to form rust? So we have oxygen and water. 2. Which metal is used to galvanize iron? It is zinc over here. So galvanization is basically a process where the iron is coated with any metal which has to be more reactive than iron, so that instead of reacting with iron, oxygen and water would react with zinc, and that would prevent the iron from rusting. F. The hull of a ship is made from steel, mainly iron. metal blocks are placed on the ship's hull to prevent rusting. Use your knowledge of the reactivity series to explain why magnesium is suitable to use as the metal blocks. Copper is not suitable to use as the metal blocks. So once again here, this is sacrificial protection. So instead of reacting with steel or iron over here, oxygen and water would react with magnesium, and that would prevent the iron from rusting. So we can use magnesium because magnesium is more reactive. However, in comparison to iron, copper is less reactive. So that would mean, despite having copper barriers on the hull, oxygen and water would still react with iron. So that would be of no use. And that is why we need a more reactive metal like magnesium to be used over here. G. Rust contains iron oxide. Phosphoric acid can be used to remove rust from an iron object and prevent further rusting. 1. Write a chemical equation for the reaction between iron oxide and phosphoric acid to form iron phosphate and water. Right, so we have the formula of iron oxide as Fe2O3 reacting with phosphoric acid. And this 3 over here denotes that the charge of the phosphate charge is -3. And so we can use this to form the formula of iron phosphate. Since iron here also has a charge of 3, has a valency of 3, and similarly phosphate has a valency of 3, they can cancel each other, and that is to say we only need one iron atom to react. We only need one iron atom to cancel out the charge of one phosphate ion. And so this is the formula. Plus we also have water forming over here. And that's it. And we only need to now balance the equation. We have 2 over here and here as well. Iron phosphate is an insoluble salt. Suggest how the formation of iron phosphate prevents further rusting. So since it is insoluble, it does not get dissolved in water, and that would mean by forming an impenetrable barrier over here on the surface, it would prevent the oxygen and water from further reacting with the iron of the hull, and so it prevents formation of rust. And that's it. We are completed with this paper. Thank you for watching.